Welcome to AI Frontiers, the podcast that journeys to the very edges of artificial intelligence. This week, we're diving into a treasure trove of new research that hit the arXiv preprint server on November 30th, 2025. We're focusing on the vibrant area of computation and language, exploring the cutting edge of AI and human communication, synthesizing recent breakthroughs, and unpacking key themes, findings, and future directions. Our journey ahead begins by setting the stage for the dynamic field of computation and language. We'll then delve into the dominant research themes shaping the landscape, highlight critical findings and the methodologies driving progress, spotlight seminal papers and their groundbreaking contributions, and finally chart the course for future research and development. The field of computation and language, often abbreviated as cs.CL, is where artificial intelligence truly meets human communication. It explores how computers can understand, process, and generate human language. This field powers essential technologies like voice assistants, translation apps, and sophisticated content generators. It is fundamental for enabling natural and effective human-AI interaction, pushing boundaries in natural language processing and understanding, and ultimately driving AI's ability to comprehend and express complex ideas. Our first dominant theme is enhanced reasoning and problem-solving capabilities. Researchers are actively pushing large language models beyond simple pattern matching towards more complex multi-step thinking. For instance, the paper Lightweight Latent Reasoning for Narrative Tasks explores ways to make reasoning more efficient, allowing models to intelligently skip unnecessary processing steps, particularly beneficial for tasks like storytelling. Additionally, rectifying LLM thought from lens of optimization refines existing reasoning steps by viewing LLM reasoning as an optimization process to be continually improved. The second major theme is model efficiency and resource optimization, addressing the high computational demands of large language models. The paper, Think Before You Prune, Self-Reflective Structured Pruning for Reasoning Language Models, tackles model compression by aligning pruning decisions with the model's actual reasoning dynamics, aiming for significant size reduction. Complementing this, 4/6, more accurate NVFP4 quantization improves hardware efficiency with novel quantization algorithms that boost accuracy, making these powerful models more accessible for resource-constrained hardware. Our third critical theme is reliability, verifiability, and safety, a paramount concern for building trustworthy AI systems. The paper Cairns, Balancing Readability and Scientific Accuracy in Climate Adaptation. Question answering focuses on delivering credible answers by prioritizing readability and verifiable citations. In parallel, beyond SFT, Reinforcement Learning for Safer Large Reasoning Models explores enhancing AI safety through reinforcement learning, demonstrating that RL provides more consistent safety improvements and better reasoning capabilities compared to traditional supervised methods. The fourth vital theme is understanding and interpreting LLM behavior, as researchers strive to peer inside the black box of AI decision-making. The paper Latent Debate, a surrogate framework for interpreting LLM thinking, introduces a novel approach that analyzes implicit internal arguments within a single model. This framework offers insights into model decision-making and shows promise for detecting hallucinations by correlating debate patterns with the risk of generating incorrect information. Finally, a crucial emerging theme is multilingualism and inclusivity, focusing on extending AI benefits beyond dominant languages. Swiveriso, the South African Next Voices multilingual speech dataset, is a significant resource, boosting automatic speech recognition for 7 South African languages. Similarly, BHRAMIL, a benchmark for hallucination recognition in multiple Indian languages, addresses specific gaps in research for Indian languages, underscoring a commitment to making AI work for diverse global populations. Summarizing the critical insights, we've seen significant model compression achieved for reasoning LLMs without performance loss, as demonstrated by Wang and colleagues. Robust and interpretable methods for evaluating LLM reasoning and identifying failures have been developed, notably by Kim and John's teams. Strides have been made in multilingual AI, encompassing speech processing and hallucination detection, with contributions from Maravites and Turdalkar's groups. Furthermore, LLM training efficiency with low-precision formats has been advanced by Cook et al., and Kim's work has enhanced our understanding of how prompt specificity impacts reasoning. Several key methodologies are driving progress in the field. Chain of thought, or COT, prompting and its refinements are used for complex reasoning tasks. Pruning and quantization techniques are employed for model compression and efficiency. Reinforcement learning, or RL, is increasingly utilized for alignment, safety, and optimization. Specialized benchmarks and evaluation frameworks are crucial for robust assessment, and multi-agent systems and language acquisition simulations offer novel approaches for deep analysis. Our first seminal paper is Cairns, Balancing Readability and Scientific Accuracy in Climate Adaptation, Question Answering by Liang-Ji Kong and colleagues. This work empowers domain experts with accessible climate adaptation knowledge, utilizing a structured scholar guide prompt for effective synthesis. Notably, it operates without extensive domain-specific fine-tuning and employs a consistency-weighted hybrid evaluator for robust assessment, holding significant impact for fields like climate-smart agriculture. Our second seminal paper is Detail Matters, Measuring the Impact of Prompt Specificity on Reasoning in Large Language Models, by Olivia Kim. This research systematically quantifies the effect of prompt detail on LLM reasoning, introducing the detail framework for measuring prompt specificity. Using GPT-4 for prompt generation and Perplexity for specificity assessment, findings indicate that increased specificity improves accuracy, especially for smaller models, offering practical guidance for effective prompt engineering. Our third seminal paper is Think Before You Prune, Self-Reflective Structured Pruning for Reasoning Language Models, by Xian Wang and colleagues. This paper addresses the challenge of deploying resource-intensive reasoning, LLMs, by proposing RESP, a self-reflective structured pruning framework. It aligns pruning with the model's star-own self-generated reasoning traces, star, me, r, achieving near-dense accuracy at 20 to 30% sparsity, and enabling efficient reasoning LLMs for wider deployment. Looking at future directions, we anticipate intensified research in efficient training and inference techniques, crucial for wider accessibility. There will be a continued focus on interpretability and explainability to build trust and ensure safety, especially as AI integrates into sensitive applications. Accelerated development in multilingualism and global AI inclusivity is expected, aiming to serve a truly global population equitably. Further exploration into AI agents capable of complex, long-horizon tasks will continue, alongside ongoing efforts to address hallucination and factual grounding across all domains and languages. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. This synthesis was generated using AI tools, including Google's Gemini 2.5 Flash Lite and text-to-speech powered by Deepgram, with image generation utilizing Grok AI. Content underwent review by a human expert for coherence and accuracy, acknowledging potential oversights despite rigorous review. Subscribe to our YouTube channel for more deep dives into AI and get the latest insights on groundbreaking research. Support our mission to explore the frontiers of artificial intelligence. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.